Welcome to our STEAM project number 6. Based on the BBC Microbit, the GeekPy Microcar and Microsoft MakeCode, in which we are going to make our robot car to drive independently without bumping into obstacles along the way. This course is at the introductory level. We actually assume that you don't have any prior knowledge of programming, sensors, or actuators. We call this level the Scout level. My name is Peter. I am the founder of Educomondo and a certified STEAM instructor and course developer. In this project, we will learn how to work with a popular ultrasonic sensor, the HC-SR04. We will show you how to connect the sensor to the microcar and select and install the right extension. We will start reading the distance from the sensor and link those measured distances to a motor action. We'll have quite some work ahead of us, so let's get started. The ultrasonic sensor works on the principle that sound waves will bounce back when they hit an object. By transmitting an ultrasonic sound and measuring the time that it takes to capture the echo of the sound, we are able to calculate the distance between the sensor and the object. Because the speed of sound is a constant, which is around 1,234 kilometers per hour in air of 20 degrees Celsius. There is a special connector in the front of the robot car where the 4 pins of the sensor fit in. Those pins are pin 12 for the trigger pin, which controls sending out the ultrasonic sound, and pin 9 for receiving the echo. The other pins are to feed power to the sensor, the volt pin, and there is also the ground pin. Of course, to make the microcar move, we need to activate the motors. If you are unsure about how to control the DC motors, have another look at the previous projects. Let's go to the MakeCode block programming. Here we are in the Microsoft MakeCode environment. Create a new project, give it a meaningful name, like for instance, Robot Car Ultrasonic. Hit the create button and we are in business. Don't forget that the first thing we want to do is to disable the BBC microbits on board LEDs, because that just might create pin conflicts with our robot car. We go to the function LED, more, let enable false, and we leave it there in our on start block. I'm just going to make this a little bit bigger so that it may be easier for you to follow. That's better. So the next step is to program the motors to go forward, forward left, and stop. In this project, that's all what we need. We have already done this in the previous project, so there are no more secrets for anyone. So let's start with forward. How do we do that? Well, we create a function, make a function, call it forward, hit done. The function appears on the canvas, and now we have to fill the function with digital writes on our pins that control the motors. So digital write, control copy, copy it 3 times so that we have 4 in total, because the motors are controlled with 4 pins. And those pins are pin 13, pin 14, pin 15, and pin 16. And I think by now you know by heart that to move forward we have to initiate pin 14 and pin 16. That's for the forward function. To create similar functions, just have to copy paste, and my new function is created, and I'm going to call it left. And to go to the left, I only have to activate pin number 16. And the last function that I'll need is the stop function. And that's a very easy one, because all of the digital writes have to be put to 0. I'm going to tuck these functions away so that they are not going to interfere with the rest of our programming environment. And the next step that we need to do is to install an extension. So go to extensions, and in the search bar we are going to type HC SR04. Hit the magnifying glass, and we are going to select sonar. Once the extension has been installed, you can click on it to see what all the options and all the blocks are. And as you can see, it is a very simple one because there's only one block. I don't think it could be any easier. Now, to make this work, we need to place this block in a variable function. Click on the function variables, and the only option, once again, you see, is to create a variable. Create a variable by giving it a name. So click on make a variable, and we will call it distance. You see that the new function is, or some new functions are created automatically, and for our project we select set distance to 0, and we drag this to the forever block. Now we don't want, of course, the distance to be 0, but we want it to be the outcome of the ultrasonic sensor. So we are going to replace this 0 with the sonar block. Now we know that the trigger pin is not 0, but it is 12. The echo pin is pin number 9, and the unit is not microseconds, but we're going to put it to centimeters. The next step is to have a logic built that will check for a minimum and a maximal distance. That distance will trigger a stop of the robot car for a couple of seconds or for a short period of time, make it turn and continue until it encounters another obstacle. So we need to create a logic, an if, and this time I'm going to make the canvas a little bit smaller. We have to compare two values. So once again, we're going to select the Boolean and replace the true. Go back to logic and comparison 1, logic comparison 2. So if, and here we are going to use our variable, our distance. As you can see, it has been created. So if the distance is larger than 0 and our variable distance is smaller than 15, and remember that we have created the unit in centimeters, then what do we want? Well, we first want to make the car stop, to think for a moment. Oh, there is an obstacle. What do I need to do? So I'm going to call my function stop. And I'm going to make it stop for, let's say, half a second. So introducing a pause of half a second. You cannot make it too short because then the robot car tends to not react to a new obstacle in the correct way. So you have to give it some time. And I found out half a second is just fine. Now it stops, it waits half a second, then it has to turn. And so I'm going to call my call left function. And this time I'm going to wait for a second. So it's going to turn for a short while, but not too short, because otherwise it may bump into the object that it just tried to avoid. So I'm going to put 1 second. So that's what happens if, of course, there is no obstacle detected. Then we can just go to the else. So I'm going to put here else. And what is the else? Well, that's just the function to drive on happily, to move forward happily. We don't need to overcomplicate this program. This will work just fine. At least that's what I hope. So let's upload the code to the BBC microbit and the robot car. Once you have done that, you can disconnect the USB cable and switch on the car. Then put it in a place with a number of obstacles and see what is happening. Here you can see that the car is finding its way, avoiding the obstacles. Here are some ideas. There is a lot of additional programming that you can do with this project. You could, for instance, add a backward motor movement, or you can add a sound that starts from 20 centimeters, so when the car approaches the 15 centimeter. You can even turn the microcar into a measuring device by adding the OLED display that will output the distance in centimeters. This is also a nice project to talk about bats and their sonar system to navigate while they are flying around. That's it for project number 6, in which we were able to make the microcar drive around independently without bumping into obstacles. In our next project, project number 7, we will control the microcar with an infrared remote. Bye bye for now.